Mining and processing of earth elements in northern China has caused years of toxic leaking into surrounding waterways.
In 2002, scientists released thousands of healthy blue crabs into the Lafayette River in Virginia, United States, a river so polluted and toxic that even fish struggled to survive in its waters. At the time, many experts believed the crabs would not last long. Others warned they would be wiped out by predators before they could ever establish a population. But what began as a controversial experiment in 2002 turned into one of the most unexpected environmental success stories in the United States. Because the crabs didn't just survive, their population began to recover in ways no one thought was possible. And most importantly, they triggered a slow recovery of the entire ecosystem. This is the story of how blue crabs helped save a dying river. Let's dive in. Toxic River. Grave long before a single crab was released into the Lafayette River. The river was already fighting for its life. This waterway feeds into Chesapeake Bay, but by the year 2000, it no longer resembled a healthy river system. Thick black mud settled across the riverbed. Heavy metals accumulated in the sediment. Industrial toxins spread through every layer of water. The river slowly turned into an environment where life struggled to survive. And the signs of collapse were everywhere. Murky water blocked sunlight from reaching underwater plants. Massive algae blooms spread across the surface, consuming large amounts of oxygen. And as summer temperatures rose, dangerous dead zones began forming along the river bottom. In these zones, oxygen levels dropped so low that survival itself became difficult. Fish gasped at the surface. Some died in place. Others fled if they could. From above, the river still appeared alive. But beneath the surface, a very different reality was unfolding. And the deeper scientists looked, the worse it became. Researchers found something alarming. Liver cancer affecting nearly 90% of local fish populations, a figure that shocked even experienced marine biologists. At this point, many experts no longer described the Lafayette River as a damaged ecosystem. They described it as a crime scene. But the river was only one part of a much larger collapse. Across Chesapeake Bay, another crisis was unfolding. The steady disappearance of the Atlantic blue crab, one of the region's most important species. These crabs played a critical role, cleaning the riverbed, supporting the food chain, and sustaining a fishery worth hundreds of millions of dollars. But between 1990 and 2000, their population collapsed. Adult females were hit the hardest, with numbers dropping by 84%, from nearly 80 million. Overfishing removed breeding females before they could reproduce. Pollution destroyed the shallow nursery habitats where young crabs were supposed to grow. At the same time, underwater grass beds, once a vital refuge for juvenile crabs, began disappearing. Without them, baby crabs were exposed in open water, surrounded by predators in a barren, lifeless environment. Very few survived long enough to reach adulthood. Scientists called this a bottleneck effect. Food still existed. Adult habitats still existed. But the next generation was collapsing before it could even begin. Traditional solutions weren't working fast enough. Fishing restrictions took years to show results. Cleanup efforts moved slowly across the system, and with every passing season, the decline continued. The future of the river system looked increasingly unstable. Yet amid all this destruction, a group of scientists began to question something unexpected. Maybe the problem wasn't just the river itself. Maybe the missing piece was something no one had considered before. And their answer would lead to one of the most surprising ecological experiments ever attempted. Crabs. Before cleanup, Most people looked at the Lafayette River and saw only one solution: clean the pollution first, bring back the wildlife later. That idea sounded reasonable, and for many years, it guided restoration projects across the country. The message behind it sounded almost unbelievable. They did not want to save the blue crabs by repairing the Lafayette River first. They wanted to help the Lafayette River by bringing back the blue crabs first. That single idea changed everything. The proposal sounded bold, risky, and unlike anything most people expected to hear from scientists. Not everything had vanished. Not everything had broken beyond repair. Hidden beneath years of decline, they believed the foundation for recovery still existed. That belief pushed them toward a strategy called stock enhancement. Stock enhancement follows a different goal. It raises animals and releases them to strengthen struggling populations in nature. The purpose is not profit. The purpose is recovery. The scale of the idea demanded support from major scientific organizations. Soon, a powerful partnership formed. The Smithsonian Environmental Research Center joined the effort. The University of Maryland Center of Marine Biotechnology joined as well. The Virginia Institute of Marine Science became another key partner. Together, they created the Blue Crab Advanced Research Consortium. Their mission focused on rebuilding a natural cycle that had stopped working on its own. As the team studied the situation, they noticed a pattern that many people overlooked. Mature blue crabs could still survive in parts of the system. The real trouble happened much earlier. Tiny young crabs faced enormous dangers long before they reached adulthood. Researchers called this recruitment limitation. New generations never reached the stage where they could replace older animals. This discovery pointed toward a possible solution. If scientists could help enough young crabs reach a stronger stage of life, the population might begin growing again. But the researchers saw another opportunity. Blue crabs do much more than simply live in coastal waters. They constantly search for food. They move through the bottom layer of their environment. They turn over material beneath them as they travel. Every movement reshapes small parts of the landscape. Over time, those actions help create better conditions for other living things. The scientists believed those natural behaviors could start a chain reaction. They believed enough healthy crabs might help create space for underwater plants to return and support broader recovery. On paper, the plan looked clever. It connected biology, ecology, and restoration into one simple idea. The future suddenly seemed filled with possibility. Unfortunately, the scientific world saw something very different, and the strongest resistance was still waiting just ahead. Scientists declare war. The proposal did not create excitement across the scientific world. It created resistance. As soon as researchers shared the plan, warnings arrived from every direction. Some felt the team was preparing to repeat mistakes that had already failed in the past. Others believed the entire idea ignored basic lessons from marine science. The project suddenly faced a wall of opposition that seemed impossible to break. During those years, several countries had released huge numbers of tiny marine animals into open waters. Officials hoped those releases would strengthen declining populations. Instead, most programs produced almost no measurable improvement. Many scientists called those efforts spray and pray projects because success depended more on luck than planning. Those failures still lingered in people's minds. The new proposal looked dangerously similar. Confidence quickly turned into doubt. Traditional ecologists raised another concern. They believed life inside controlled facilities could change animal behavior in ways that nobody fully understood. They worried that hatchery-raised blue crabs might lose important survival instincts. These critics argued that wild environments teach lessons that no tank can provide. They feared the released animals would struggle to find food, avoid danger, or compete with experienced wild crabs. Some researchers even used the term Franken-crabs to describe them. The nickname spread quickly and fueled more criticism. Public support began to weaken as the debate grew louder. Fisheries managers focused on another threat. Blue crabs are not peaceful creatures. They compete fiercely for food and territory. Larger individuals often attack smaller ones. Studies showed that when protective underwater vegetation disappears, survival rates for young crabs collapse. Research suggested that 75% to 97% of juveniles could disappear before reaching maturity. The expensive project could fail within days. The warnings became harder to ignore. Toxicologists brought another problem to the table. They focused on the contaminated conditions inside the Lafayette River. They worried that harmful substances buried in the sediment could weaken the animals over time. Exposure to pollutants might damage their health long before researchers noticed any visible signs. Some experts feared that hidden stress could make them more vulnerable to infections and environmental changes. The risks extended beyond simple survival. Then another concern appeared. Genetic specialists warned about possible contamination of the wild population. They feared that hatchery-raised crabs could introduce unwanted traits or harmful diseases. Some researchers pointed to threats such as the Rioiki virus and imagined devastating consequences if pathogens escaped into natural waters. The fear spread through scientific circles and moved forward anyway. But if they were going to attempt the impossible, they first had to solve a problem that had defeated biologists for decades: building perfect crabs. Moving forward required much more than confidence. The team needed a way to produce strong young blue crabs in large numbers. That challenge sounded simple from the outside, but inside the laboratories it became one of the hardest tasks in the entire project. Blue crabs do not cooperate with people. They follow ancient instincts that developed over millions of years. Researchers could not simply place them in tanks and expect success. Every stage demanded patience, precision, and constant attention. The entire mission now rested on a problem that had frustrated experts for decades. Many scientists had tried before. Very few had come close. Success requires perfect timing at every step. One small mistake could wipe out months of work. The challenge felt more like solving a giant puzzle than raising marine animals. A remarkable process slowly took shape behind closed laboratory doors. The team carefully adjusted water temperatures throughout the year. They also controlled daily light exposure. These changes created artificial seasons inside the facility. The crabs responded to those signals as if nature itself had changed around them. The researchers essentially guided their biological clocks toward reproduction. Step by step, the animals entered spawning conditions. Progress remained slow, but the system finally started producing results. The hardest stage arrived immediately after spawning. Tiny larvae entered the world almost invisible to the human eye. At this size, survival depended on constant care. The team developed specialized feeding programs using rotifers and brine shrimp. Every feeding schedule required careful planning. Every tank required close observation. The smallest imbalance could destroy an entire group. Day after day, technicians monitored conditions and protected these fragile creatures through their earliest stages. Yet another obstacle waited just ahead. As the juveniles grew larger, a different threat emerged. Blue crabs are naturally aggressive. They compete for space and resources from a very young age. When crowded together, they attack each other without hesitation. A single tank could quickly become a battlefield. The researchers needed a completely new solution. They began designing miniature living spaces inside the nursery systems. Innovation transformed the project once again. The team installed mesh structures throughout the tanks. These designs gave individual juveniles places to separate from one another. The setup worked like a substitute for underwater vegetation that no longer existed in many waterways. Instead of constant fighting, more animals survived and continued growing. The scientists were no longer simply raising crabs. They were building a carefully managed force for a much larger mission. The Great Release. The long preparation period finally ended. In 2002, the project moved beyond plans, paperwork, and laboratory work. The real test had arrived. Everything that happened next would take place in the open world, far away from controlled conditions. Between 2002 and 2006, teams carried out a series of carefully organized deployments across tributaries connected to Chesapeake Bay, because nobody could predict what would happen after the animals entered the water. Years of work now depended on a few critical moments. The operation demanded precision from start to finish. Workers transported young blue crabs from protected facilities to outdoor launch sites. Each deployment included between 4,000 and 10,000 juveniles. The animals faced a stressful journey before reaching their destination. Teams monitored conditions closely during transport and handled every group with extreme care. The goal was simple: deliver healthy juveniles to the target areas without causing unnecessary losses along the way. Every successful arrival felt like a small victory before the larger battle even began. But another challenge quickly appeared. Releasing the animals was only part of the mission. Researchers also needed proof of what happened afterward. Without reliable tracking methods, nobody could tell whether the project succeeded or failed. The team needed a way to follow individuals after they vanished beneath the surface. This requirement pushed the project into a new level of innovation. These tags remained hidden from sight, but stayed detectable later through special equipment. Even after growth and shell changes, the markers remained in place. Some individuals also received colored polymer markers beneath their shells. These markers created another layer of identification. The project no longer involved releasing animals alone. It involved releasing information that scientists could recover later. The technology transformed every deployment into a living experiment. Release day carried a strange mix of excitement and fear. Boats moved toward designated locations while researchers prepared their equipment. Dr. Anson Hines and his team watched closely as thousands of juveniles entered unfamiliar surroundings. Some entered exposed mud flats. Others entered areas connected to restoration work supported by the Lafayette River project. One by one, wave after wave disappeared beneath the surface. The uncertainty felt overwhelming. The water itself added to the tension. To gather clues, researchers turned to ultrasonic telemetry. They attached acoustic transmitters to selected individuals and monitored signals using hydrophones. Every sound offered a small piece of the story unfolding below. Yet no amount of technology could reveal the final outcome. The deployment was complete. Human control had reached its limit. From that moment forward, natural forces would decide everything. Then the first survival data arrived, and it immediately shattered everything the critics had predicted. Shocking results emerge. The waiting period did not last long. Within just 48 hours of the first deployment in 2002, researchers recovered some of the marked juveniles. Everyone expected signs of struggle. Instead, the findings delivered a completely different story. Scientists examined stomach contents and discovered that the young animals had already adapted to their surroundings. The behavior looked natural and confident. Nothing matched the gloomy predictions that surrounded the project before it began. The early evidence immediately changed the mood around the experiment. More surprises soon followed. As months turned into years, researchers gathered larger sets of information. The numbers became impossible to ignore. In marine biology, only a tiny fraction of young individuals usually reach adulthood. Many observers expected even lower performance from the released juveniles. The opposite happened. By 2006, survival estimates ranged from 5% to 20%. Those figures stunned experts across the field. The outcomes exceeded expectations and challenged long-held assumptions about population recovery. Momentum continued to build. Another major breakthrough arrived during high-density deployments between 2011 and 2013. A deeper explanation slowly emerged from the data. The answer did not come from laboratory calculations. It came from the physical landscape itself. Restored oyster reefs changed everything. Their complex shell formations created natural protection and shelter. These structures reduced losses and gave young individuals better opportunities to grow. The discovery revealed an important lesson. Physical habitat mattered more than many people realized. The environment provided support that no amount of theory could fully predict. The story became even more remarkable. Researchers noticed important changes across the surrounding area. Seagrass coverage increased from roughly 15% to over 30%. Healthier underwater conditions began appearing in places that once struggled to support life through normal daily activity. The ecosystem started responding in ways that encouraged further recovery. Progress no longer appeared limited to one species alone. Then came the final confirmation. Tagged females completed their natural journeys and reached spawning areas successfully. Reports from watermen miles away verified their movements. The population began showing signs of stability. The project succeeded. The warnings, doubts, and predictions of failure gave way to measurable results. But the most surprising part of the story wasn't what happened to the crabs, it was what happened to the river itself. The gamble worked. The blueprint existed. And the lesson reached far beyond Chesapeake Bay. What makes this story so powerful is that it was never just about blue crabs. It was about people refusing to give up on a place that many believed was already lost. Do you think more environmental projects should take bold risks like this, even when success seems impossible? Share your thoughts in the comments below. If you enjoyed this video, make sure to give it a thumbs up. And if you don't want to miss more incredible transformation stories like this one, subscribe to the channel. We'll see you in the next video. Until then, thanks for watching.